Hello class, in this video I'll be applying the law of sines to find the missing side lengths and angles of a triangle. Let's begin. Solve the following triangle using the law of sines. Round answers to one decimal place. So I'm going to go ahead and insert the given information into this triangle right now. So what is left is side length B, side length C, and then angle C. And before we begin, I want to know which property of geometry is given. Is it angle, side, angle, 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 side? And it looks like what's given is angle, angle, and a non-included side. So this will be angle, angle, side, which implies that one triangle exists. So let's go ahead and determine the values of the remaining side lengths and the remaining angle. And I'm going to start with the angle because I believe that's probably the easiest. So angle C is going to equal 180 minus the sum of the other two angles. And remember that 180 degrees is the sum of the three angles of any triangle. So this is going to equal 180 minus 60, which is equal to 120 degrees. So angle C is equal to 120 degrees. And I'm going to write that in the triangle right now. And now that we found angle C, let's go ahead and find side C. From the law of sines, sine of 120 degrees divided by C has to equal sine of 40 degrees divided by 2. And to solve for C, I'm going to start by cross multiplying. So C times sine of 40 degrees is equal to 2 sine of 120 degrees. So that way C is equal to 2 sine of 120 degrees divided by sine of 40 degrees. And I'm going to evaluate that in Desmus. So before you evaluate this in Desmus, make sure you hit the wrench and you hit degree. Because if you don't, you're going to get this problem wrong. Because Desmus automatically defaults to radians. So make sure you're in degrees. So this will be 2 sine of 120 degrees divided by sine of 40. And it looks like side length C is approximately 2.7. And finally, we can find side length B. And applying the law of sines, sine of 20 degrees divided by B has to equal sine of 40 degrees divided by 2. Cross multiplying and isolating B, you get B is equal to 2 sine of 20 degrees divided by sine of 40 degrees. So going into Desmus, that's approximately 1.1. Okay, so B is approximately 1.1. And so now that we have determined all of the remaining side lengths and the remaining angle, let's just make sure that these values make sense. Okay, so all of our calculations are correct. I just want to see if this information actually makes sense. So starting with the smallest angle, is the side opposite of the smallest angle the smallest side? And that answer is yes. Is the opposite side of the middle angle the middle side length? And that answer is yes. Is the opposite side of the largest angle the largest side length? And the answer again is yes. So we have now finished the problem.